We are currently facing a moment that can be briefly put like this. China is betting not on a single project, but on an entire ecosystem, on an industrial scale, on speed, and on scaling. And that makes things interesting because what's happening there right now has less to do with a momentary victory and more with building supply chains and launch cycles. Here's a brief overview. Alongside the government programs, a whole wave of semi-private rocket companies is growing in China, and they all have one thing in common. Many are taking a close look at what SpaceX has done and are adapting exactly the components that make sense both technologically and economically. That means methane and liquid oxygen engines are becoming popular, larger payload classes are being tackled, and reusability is on the roadmaps. Sometimes a bit greener than at SpaceX, sometimes surprisingly directly copied, sometimes as a hybrid between Falcon 9 and Starship design. My name is Serwan and this is Mars Chronicles. Here are a few names you should remember. Landspace is one of the more visible companies. Equally important are Galactic Energy, iSpace, Space Pioneer, Deep Blue Aerospace, and Link Space. Some are purely private, while others work extremely closely with provincial governments and state partners. This creates a very Chinese hybrid model. Market-driven speed combined with political support. What stands out at the moment? Three things. First, iteration instead of perfection. The startups launch early, often, and publicly. Mistakes are part of the development, not the end of it. That's a culture that has so far been associated more with the USA. In China, it's now emerging as well, although with different political conditions. That speeds things up. Second, standardization and scaling. It's no longer just about a cool prototype. Many teams are building production lines, modular upper stages, and standardized tanks. That's important if you really want to reduce the cost per launch. Third, technology mix. Some companies are focusing heavily on methane and LOX engines. Others are improving classic RP1 designs. When it comes to reusability, every approach is on the table. From vertically landing first stages to reusable upper stage experiments. And yes, some designs look like they've gone through a SpaceX filter, but many teams combine this inspiration with local engineering knowledge and their own manufacturing skills. Politics and money play a key role. Beijing incentive programs, provincial subsidies, and military supply chains keep many projects alive, even when commercial orders are not yet coming in large numbers. At the same time, this means that technical milestones are celebrated as political wins, which creates pressure but also provides resources. What are the risks? Well, the usual ones. Launch and test failures, like when Space Pioneer conducted a static fire test of their first stage for the Qianlong 3 rocket and the rocket unintentionally lifted off. In times like these, supply chain shortages also have to be taken seriously. And striking the balance between quality and speed is also of utmost importance. Additionally, there are also regulatory uncertainties. China's spaceflight ecosystem is in flux, and regulations for private launch vehicles are still a patchwork. Companies can survive on a provincial subsidy or be slowed down by a regulatory change. Briefly, a word on bigger topics. China has ambitious infrastructure plans, from larger orbital activity to the joint ILRS initiative with Russia. The question is not just who flies the most, but rather who builds the logistics, the depots, the ground and launch infrastructure that makes permanent presence possible. And that's exactly where many Chinese players are quietly investing. Why should we pay attention to this? Because an alternative model is taking shape here. Not an exact copy, nothing like Western methods. Instead, it's their own mix of state planning, private entrepreneurship, and an extremely fast pace. If that works, it will change the geopolitical equation. Frequent launches, low costs, and local manufacturing mean that spaceflight is no longer the domain of just a few nations. If you take a closer look at China's private launch sector, you quickly realize this is not a homogeneous group. There are winners, there are companies on shaky ground, and there are firms that are just now learning how brutal spaceflight really is in practice. Let's begin with the most famous name, Landspace. Landspace is something like the Chinese answer to SpaceX's early development path. Their focus is clearly on methalox. In other words, the same fuel path SpaceX took with Raptor and Starship. The Zhuge 2 rocket is the real test here. After a failure on the maiden flight, Landspace made improvements and eventually achieved a successful orbit. The crucial thing is not the success itself, but the learning curve. Landspace has shown they can absorb mistakes, adapt hardware, and fly again. That's the most important quality in this business. In December 2025, they launched their new Suke 3. The launch was successful, but the propulsive landing didn't go as planned. The entry burn of the booster worked, but something went wrong during the ignition for the landing burn. That led to the upper stage bursting into flames and crashing without braking at all, just next to the designated landing zone. The precision here is quite remarkable. If you're already enjoying this video, hit the hype button if you have it. If not, a like, a subscription, or a comment helps the channel a lot. The algorithm will decide in the next few months whether to keep spreading this video or not. And you have a say in that. Thank you. And let's continue. Then there's Galactic Energy. Galactic Energy seems more conservative at first glance. The Series 1 uses conventional propellants, is small, reliable, and flies relatively regularly. This isn't a Starship moment, but rather the Chinese counterpart to Rocket Lab's early Electron years. Less vision, more cash flow. And that's exactly what makes the company dangerously competitive. They fly often, they deliver payloads, and they build trust with customers. At the same time, they are working on larger launch vehicles, but without losing focus. iSpace is the counterexample. Big ambitions, aggressive schedules, but several setbacks. Failed launches with the Hyperbola series were especially painful. iSpace wanted to move quickly toward reusability, but Spaceflight doesn't forgive shortcuts. The company still exists and continues to work, but it's a good example of how copying SpaceX doesn't automatically give you SpaceX's pace. Space Pioneer is very exciting. This is where it gets interesting, because Space Pioneer is very open about experimenting with Falcon 9-like architectures. Large first stages, clustered engines, clear reuse goals. Their Tianlong rocket is ambitious, maybe even too ambitious for its current level of maturity, as we saw in this failure. But these are exactly the companies you have to watch. Not because they are guaranteed to succeed, but because if they do succeed, they could scale up very quickly. Then there's Deep Blue Aerospace. Deep Blue is heavily focused on vertical landing techniques. The company is testing reusable suborbital vehicles and is gaining experience exactly where China has long been weaker. Precise control during re-entry and landing. That is very reminiscent of SpaceX's Grasshopper phase. No orbital flight yet, but valuable groundwork. What you see with all these companies, failed launches are no longer career-ending. In China, they are increasingly being accepted as part of the process. That's new. 10 years ago, a spectacular failed launch would hardly have been politically acceptable. Today, it is analyzed, put into context, and the work continues. And it's at this point that you notice something important. In the end, what matters in the end is not the rendering, but the hardware. We constantly talk about methane engines, landing maneuvers, reusability, but that often remains very abstract. That's why I built something that makes this whole discussion tangible. This is a 3D printed model of a Raptor 3 engine from SpaceX. It's printed on a Prusa printer. Once you have a part like this physically in front of you, you really understand how absurdly complex modern space technology has become. Cooling channels, pipes, turbopumps, delicate geometries. Things that used to be made only in highly specialized factories can now be placed right on the table as demonstration objects, and that's exactly what makes Prusa so exciting for me. Reliable, precise 3D printers that not only allow you to explain technology, but actually make it visible and tangible. For education, for prototyping, for model building, or simply to bring spaceflight from theory into reality. Of course, I'll link the Prusa printer and the model for you below in the description. But let's get back to China's space program. Now, a quick look at the numbers because they're crucial. China has massively increased its launch frequency in recent years. In 2023 and 2024, there were clearly well over 60 orbital launches each year. As of now, 2025 is once again in that range. With a growing share of commercial missions, the trend is clear. China is not only launching a lot, but is increasingly using new launch systems. That is technologically risky, but strategically sensible. At the same time, China operates its own space station, Tiangong. It is smaller than the ISS, but it is fully functional and permanently manned. What matters here is not so much the size as the independence. Tiangong is a testbed for long-term operations, resupply flights, and crew rotations. Exactly the know-how that will be needed later for the Moon or cislunar infrastructure. And that brings us to the big picture. ILRS, the International Lunar Research Station, which China is planning together with Russia, is not an Apollo copy. It is designed for the long-term, modular, built step by step, and prepared through robotic groundwork. Many things are still in the concept and rendering phase. But the political intention is clear. China doesn't just want to land, China wants to stay. They are also one of the most important driving forces behind Artemis. When you put all of this together, a clear picture emerges. The Chinese space strategy is not based on a major prestige project, but on breadth. Many companies, many approaches, many launches. Some will fail, but those that remain form an ecosystem that can be scaled quickly. If you compare China's space strategy with that of the USA, a fundamental difference becomes apparent. The USA is currently relying heavily on a few extremely dominant players. First and foremost, SpaceX, Falcon 9, Falcon Heavy, Starship. That's not an ecosystem, that's a monolith with enormous power. If that works, the lead will be gigantic. If it fails, there's little redundancy. If that works, China is deliberately taking the opposite approach. Not one company, rocket, or architectural leap, but many parallel paths. Landspace, Galactic Energy, Space Pioneer, Deep Blue, and iSpace. They compete with each other, copy from one another, and learn collectively at the same time. That is inefficient in detail, but extremely robust at the system level. The price for this is obvious. China currently does not have a rocket that can match the operational maturity of a Falcon 9. Reusability so far exists almost exclusively on the test stand or in suborbital demonstrations. There is no Chinese rocket that launches, lands, and launches again week after week. And above all, there is no Chinese company that runs spaceflight like industrial mass production, at least not operationally. While SpaceX is making a single massive technological leap with Starship, China is focusing on evolution. Bigger rockets, gradual reuse, higher launch frequency, more operational experience. The goal is not the spectacular solution. The goal is control over launch capacity, logistics, and cadence. And that brings us to the structural weaknesses of this approach. 1. Quality assurance. Many companies mean many supply chains. That increases the likelihood of recurring defects. 2. Transparency. Launch failures are more accepted than before, but causes, design changes, and real lessons learned are often hard to understand from the outside. 3. International trust. Western customers are still cautious about Chinese launch vehicles. Think export controls, ITAR, and political risks. But China compensates for exactly that with something the West increasingly underestimates: a gigantic domestic market. Chinese satellites, Chinese constellations, and Chinese military and civilian payloads. Even if not a single Western customer flies, these companies have enough work to survive, learn, and grow. And their space station Tiangong is not spectacular, but it's there. It works. And it forces China to conduct regular launches, manned missions, emergency procedures, and supply logistics. It's exactly this routine that will later determine the success or failure of lunar architectures. In the context of ILRs, this becomes especially relevant. The planned International Lunar Research Station is not a quick victory, but a long-term development. Robotics first, modular, with energy supply, communication, and logistics in focus. Not a flag-planting moment, but a sustained presence. And that's exactly what China's approach is made for. So the big question isn't, does China have a Starship today? The question is, does China even need one? Because if China has several medium-sized, partially reusable rockets in 5 to 10 years that launch reliably, frequently, and cheaply, then you can build infrastructure without a single giant leap. Maybe slower but more stable, and that's the real bet. The US is betting on disruption. China is betting on perseverance. Both can work, both can fail, but they are completely different philosophies. And that's exactly why you shouldn't dismiss the Chinese startups. Many will disappear, some will merge, but the few that remain won't be a Chinese copy of SpaceX. They will become something of their own, shaped by political backing, high launch frequency, and a market that doesn't ask for PR but for reliability. When you put all that together, the Chinese startups, the government support, the space station, ILRs, and the increasing launch frequency, it quickly becomes clear. China is not currently trying to overtake the West. They want to show that they are a world power, independent of Western launch services, independent of geopolitical supply chains, and regardless of whether SpaceX works or not. This is particularly interesting in terms of defense and sovereignty. And that's exactly where the real danger for the West lies. Not in a single rocket, not in a spectacular test, but in the sheer number of iterations. Many launches, many failures, and many small improvements. No hero, no miracle solution, no Elon moment. But rather industrialized spaceflight on an assembly line basis. The US is betting everything on speed and disruption. That can work. Starship can change everything or fail. China, on the other hand, accepts that the path will take longer, but it's controllable. The goal isn't to make the fastest leap. The goal is to still be there in the end, when others have overreached. And Europe is in between and hesitates. And too state-controlled for real iterations, too political for genuine risk-taking, too fragmented for industrial strength. While China experiments and the US escalates, Europe debates responsibilities. The uncomfortable truth is, spaceflight is back in geopolitics, not as a symbol, but as infrastructure. Whoever can launch determines the pace, speed, and dependencies, those who can't become customers or spectators. So China's bet is not a bet on the best rocket. It's a bet on endurance, learning curves, and a market that's big enough to forgive mistakes. And that's exactly why these companies should be taken seriously as a system. If you like these explanations, subscribe and let me know in the comments whether you think China's approach is smart or too slow for this new space era. My name is Serwin, and this was Mars Chronicles. Thanks for tuning in. Subscribe. Per aspera ad astra. A presence that makes a permanent presence possible.